Alright, here's part 3, and for part 3 here we're going to talk about rational exponent notation versus radical notation. My goodness. Well, to step through a little bit of the vocabulary here, you really need to know what a rational number is. And a rational number is any number that can be written as a over b, where a and b are both integers. So what we're talking about here is we're talking about integers or fractions. Either one for rational exponent notation. Keep in mind it says exponent. So with this notation, I'll give you just a quick example. You're going to see, and we'll just do that example over here. Example of this will be, let's say, x to the 4/5 power. Okay, so it could be an integer up here, it could be just x squared or something like that, but a lot of times you're going to see a fraction up here, and that's just a rational number. So a rational exponent would be an exponent that is a rational number, and a rational number can just be written as a fraction. Radical notation, however, is a little bit different. So radical notation, we're going to get used to this setup right here. And radical notation, there is sometimes a number out here. If there is no number, it's actually a 2, so we don't write the 2 for square root. If it's a 3, it would be the third root, 4, fourth root, and so on. And then you're going to have something underneath here, let's say maybe x to the 7th power. Okay, so this would be an example of, we'll make that an example, so some number up there, some number inside with this radical sign here. So that radical notation will be for the right hand part of this. So rational exponent notation looks like x to the 4/5 power, or x to the 3rd, or x to the 7/8. And radical notation, you're going to see a radical sign. Okay, so let's talk about what this exactly means. And to do that, I'm going to give you an example here. And this example is going to be a nice easy one. So let's do just the square root of x squared. Now, you might be already shouting this answer out at home. Don't be too loud, or else you might disturb other people in your house or wherever you are watching these videos in the classroom. So, but you know that this should be just x. Square roots and squaring, those are inverse operations. They're going to undo each other, and so that's just x. Well, this is radical notation. So I'll put a little radical right here. And what we want to do is we want to start to see how can we change this radical notation into rational exponent, and then we'll go the other way as well. So to take a look at that, what we want to do is we want to say, how can I deal with this radical sign? How do I change it into rational exponent notation? We know this is true. So if we have x squared, and we're going to change that radical sign into some kind of, I'll put a question mark up there, into some exponent, what is that? And we know that this situation here, these are the same thing. Here's x squared, and instead of a radical sign, we're just saying, what is that in rational exponent? We need this to work out to be x. This is a true statement after all, and so this must be a true statement as well. X is just x to the 1st power. Recall that if you have a power of a power, you're going to multiply those together. So this is 2 times the question mark, and if you want at home you can put a variable in there if you'd care to do that, that's fine. And that has to be equal to 1. So 2 times some number has to be equal to 1. What number is that? You're saying to yourself, well, it is definitely 1/2. 2 times 1/2 is 1. So the missing number is 1/2. So the only thing that's different between this side and that side is we still have an x squared here, and the only thing that's different is the radical is now gone, and in its place there has to be a 1/2. So we can now understand that a square root is really just raising something to the 1/2 power. Does it work for other things as well? And it turns out it does. So if you had perhaps this example, if you had the fifth root of b to the maybe third power, how do we deal with this fifth root? How do we change that from radical notation into rational exponent notation? So again here, this one is radical. And then over here on this side, we want to change that into something that looks more like a rational exponent, so kind of like this. And we can take the b to the third power, and we can raise that, just like over here, that missing number was 1/2. Here, it's not going to be 1/2. There was really a 2 up here on the ledge. It's going to be 1/5. So you can think about these radicals. Just take the root here and put that in the denominator. There'll be a 1 here in the numerator. If we multiply those together, though, as our power of power rule states we should, 3 times 1/5 is just 3/5. So let's take a look and see if we can maybe develop a bit of a shortcut now that we kind of understand the concept of what's going on. If you have a base and an exponent underneath a radical sign, the exponent of the base will be in the numerator. So I'll try to draw that. Let's see, we can go just like this here, okay? So the exponent underneath the radical sign of the base becomes the numerator. The root over here, if there's a number on the ledge, remember that if there isn't a number, it's a 2. That number will always be the denominator. We can do another quick example, and let me go ahead and I'll just write rational exponent here on the right-hand side. That's totally a rational number. It's a fraction, okay? A rational number can be written as a fraction. Remember that the 5 letters that start off rational, that's ratio. So all we're talking about here are fractional exponents. They could be integers as well. You can always write an integer like 3 as 3/1 or 6 as 6/1. So integers are rational as well, and that's okay to have in addition to fractions. So let me give you one more example, and we'll see how this goes here. So here's another example for you. Let's say that you have the 6th root of, let's go z to the third power, z to the third power. So if we use our little shortcut, you can always go back to this method right here in the middle if you want to, but it's nice to know that little shortcut. Remember that the 3 belongs in the numerator, and then the radical or the root over here will be in the denominator. If you wanted to, you can go ahead and use your fraction rules, and this is just 1/2, okay? So here's radical there's radical notation, and right here is rational exponent notation. These expressions are the same thing. They're equal. This expression is equal to this expression. We're just changing the way that it looks.